Here, I want to take a look at a few examples of some equations involving natural logarithms. So there's nothing necessarily new here, just a few things that would probably be good to take a look at, just because it kind of looks a little different. So, but hopefully you'll agree that this is not anything particularly different than what we've already been doing. So taking example, we have 4 plus the natural log of x plus 1 is equal to 7. And our goal here is to solve for x. So I'll say up front, you will need a calculator, at least in the end for this, but let's at least set it up in a way that will be easy to use a calculator. So we need to isolate x as much as possible. So first thing, we'll go ahead and take 4 away from both sides, and that'll give us the natural log of x plus 1 is equal to 3. Okay? So remember, the natural log of x plus 1 is the same thing as log base e of x plus 1. Okay? So really we have log base e of x plus 1 is equal to 3. So what this really means is we have e to the 3 is equal to x plus 1. Okay? E to the 3 is equal to x plus 1. So we can take 1 away from both sides, and we get x is equal to e to the 3 minus 1. Okay? So there we go. So if we put that in a calculator, we will have the following. So if we have e we'll end up with 19.09-ish. Okay, so nothing too crazy here. All right, so really all we're doing is getting this in a way that we could very easily plug this into a calculator. So again, nothing particularly new here, just using natural logs now instead of using uh, um, logs of other bases. All right, so here we have the natural log of x plus 2 minus the natural log of 3 is equal to negative 3. So here we can use our quotient rule for logs, but we can also express this in terms of natural logs too. So if we have ln of a minus ln of b, that is equal to ln of a divided by b. Okay, so knowing that we have here, we can write this ln of x plus 2 minus ln of 3 as ln of, or the natural log of x plus 2 over 3, and that'll be equal to negative 3. And if we use the same setup as we did last time, this is the same as saying e to the negative 3 is equal to x plus 2 over 3. Let's try that a little different. X plus 2 over 3. All right, so we can multiply both sides by 3. Can multiply both sides by 3. And we will get x plus 2 is equal to 3 times e to the negative 3. Okay, and now we can take 2 away from both sides, so we'll get x is equal to 3e to the negative 3 minus 2. And if we plug that into a calculator, we should end up with approximately 1.85 after we do some rounding. Okay, or I'm sorry, negative 1.85 after we do some rounding. Okay? All right, let's do one more. Here we have 8 plus 8 plus 3 times the natural log of x is equal to 6. So I will say, I would avoid the temptation here to go ahead and do the power rule for this 3 times the natural log of 8. And I'll show you why here in just a second. Let's take 8 away from both sides. So we'll end up with 3 times the natural log of x is equal to -2. All right, we can take 3 away from both sides, or we can divide both sides by 3, and we'll end up with the natural log of x is equal to -2/3. Okay, but since this is the same as log base e of x is equal to -2/3, we have e to the -2/3 is equal to x. And e to the -2/3 is approximately 0.51 after we do some rounding. All right, so as I said, nothing overly different here, just a few examples to take a look at and maybe help you with your homework if you got stuck on the natural log part of this.